So we took a look at our vector resolution and we saw, what does it mean? It means we're breaking it up, our original resultant, our original arrow, we're breaking it up into components. And what do we do when we break them up into components? We're breaking them up into these little arrows. So we take a look over here, component, component. And what we do from there? Well, it looks very similar to our parallelogram method. So I take a ruler and I put it down and I go straight up, parallel to the one right here. And I take my ruler and I go straight across, parallel to the one right there. And what does that give me? It gives me a resultant vector. And what's that resultant vector? Well, if our components are up and to the right, a resultant vector has to be up and to the right. So when I take my ruler and I draw it across, sure enough, that's what I get. Now let's look down here lower, more complicated one. We see this component right here. Is that the negative x or the negative y, positive x, positive y? By the way, it doesn't matter. Just tell me, left or right? It's going left. So if it's going left, I'm just going to write this on here. If you want to know, it's going in the negative x direction. And then our one below it, it's going down and to the right. So I can actually draw little tiny components, breaking it up into its x and y. To the right and down. So I see that this one's going in the positive x. And I see that this is going in the negative y. All that means is right and down. Now if I see that, I can still draw my parallelogram and it doesn't matter, where I draw this one parallel to here, this one parallel to here, and it doesn't matter because I just get my resultant. But to double check that mentally in your mind, just think about it. Just think about it for a quick second. This arrow is smaller than this one. And they're going in opposite directions. So they're going to take away from each other if they're going in opposite directions. So my resultant orange arrow right here I'm going to just draw this right here again. We better see our components less than this x, because it's subtracted, which is it less than that x? Yeah, that's less than that x. And then you better see it matching the y component right there, because there's no other y. Is that what we see? Sure is. So when we're doing this, all we're doing is we're making parallelograms from our vector resolution. And what's vector resolution again? Vector resolution is just confirming what our resultant looks like. And with what our resultant looks like is the vectors split in the x and y direction. Okay. So we took a look at vector resolution. And with vector resolution, we are able to add our x and y components to find a resultant. And with that resultant, we had an arrow. We had our components. Well, guess what? Using Pythagorean theorem, go back over here to this worksheet that we have. We see that a squared plus b squared equals c squared. I know you guys have had to have heard that before, even if it wasn't necessarily something you used. You've heard it before. It's really common. What does that mean? It means anytime you have a right angle with a triangle. By the way, right angle, what is it? It's where this is 90 degrees. That's a just straight turn. It's like a graph. Your x and y axes. Your x and y components. They're perfectly at a 90 degree. Doesn't matter which way your 90 degree is. It's at a 90 degree. And with that 90 degree turn, I'm actually going to draw this a little bit smoother. So, we have our resultant. And then we also have, actually I'm going to draw that arrow the other way. We also have our components. By the way, that is the exact same thing as if I had this over here. It's also the same if I had this up here. And a squared plus b squared equals c squared. C squared is always going to be that longest side. So this is going to be c. Well, a can be down here and b is up here. Or if you want to, you have b down here and a up there. It doesn't matter. You can have a or b either place as long as you have one on one side, one on the other side. Now I'm going to take these out for now. We're going to have a, b, and c. Now let's just give a random value. Let's say a equals 3. And this is 3 meters. I'll just say meters, given it a unit, because in physics we want to make sure we have units. It's not just math class. Let's say b equals 4 meters. Now I'm asking you, what does c equal? Well, we know a squared plus b squared equals c squared. And from that knowledge, a squared plus b squared equals c squared, we know a is 3 meters. So what do? Put 3 meters squared plus 4 meters squared equals c squared. Now we're still just looking for c. So what do? We know the square root of 3 meters squared plus 4 meters squared equals our c. The square root, by the way, is just getting that squared on the other side. It's nothing to worry about. I could even write my equation up at the top as c equals the square root of a squared plus b squared. You can actually write that down on your paper. It might help you for this exercise. I'm actually going to solve it for a as well. A would equal c squared minus b squared, all square rooted. And b equals c squared minus a squared. So you can write all those down. You can have them on your paper ready to go. But right now, we're looking for a c squared. So let's just take this. I'm moving it down here, show my work. We have 9 meters squared plus 16 meters squared. What does that equal? Well, it equals the square root of 25 meters squared. Now I take the square root of 25. What do we get? We get 5. So our c is going to equal 5. 5 what? We had meters squared. We take the square root of something squared, we just get meters. So what can we see from this? Well, what we see is that our triangle is a 3, 4, 5 right triangle. And that's actually a perfect triangle. 3, 4, 5. It's not always going to be that pretty. You're not always going to get full numbers. You'll have to type it into your calculator. You're going to have to plug it in, use that square root, figuring that out. But it's just as simple as that. We find these patterns. Remember, this resultant vector right here, this one, will always be your longest. Look, 5, it's bigger than 4, it's bigger than 3. It's your longest. Check. Your 3 and your 4 will always make a right angle to each other. Boom. Good. Check. And remember, if you have your arrows to the right here and up here, your resultant better be to the right and up combined.